Nicholas here for another edition of SignalWire in Seconds. This week, I'm practically in stitches over the impending release of Call Fabric, SignalWire's newest raiment for software-defined telecom, signifying a progression of our underlying architecture. Call Fabric threads through the sinew of traditional CPaaS, UCaaS, and CCaaS solutions, weaving their best features into an entirely new category, a grand tapestry we refer to as programmable unified communications. In this episode, I'll explore Call Fabric's novel concept of core communication components, resources, as well as addresses, the strands that bind them. Using a few key examples, I'll button up a simple IVR with our call flow builder, stitch together a SWML script vested with live transcription capabilities, and crochet a call monitoring Node.js application that compiles incoming conversation data into a CSV report. Follow along for a bonus glimpse at our newly redesigned Space UI. But please note, UI elements shown in this video are still a work in progress and subject to change before their final release. Let's get started. From the home screen of my SignalWire space, I'll navigate to the Resources tab on the left-hand side of the web page. Because I've used SignalWire before, I'll be greeted with a list of pre-configured resources, painstakingly reconstructed behind the scenes from assets that I've previously developed. Woven into the very fabric of our platform, resources represent an abstraction of interstitial programming elements that delimit video rooms, relay applications, or AI agents, just to name a few basic resource types. Subscribers are perhaps the most notable paradigm shift within the SignalWire platform. They embody authorized end users, call center agents, and the like that can be provisioned with the means to initiate outbound calls, enter a chat room as an administrator, and more. Keep an eye out for further information about subscribers in the future. To kick off my live transcription demonstration, I'll begin with a call flow resource. Utilizing the call flow builder, I'll stitch together an IVR effortlessly. Employing the answer call, gather input, forward to phone, and hang up call nodes enables me to design a fully functioning interactive voice application in just a handful of minutes. Once setup is complete, I'll press the deploy button and return to the resources overview page. To alter a saved resource, I merely need to click on the icon beside my desired selection's name in the resource overview page. Alternatively, I may enter the resource I wish to refine and navigate to the editing buttons located therein. When I'm ready to commit my changes, I'll click on the deploy button. To learn more about manipulating resources programmatically, I encourage you to inspect the Call Fabric section of our Relay Browser SDK, as well as our SignalWire REST APIs, both expertly outlined at developer.signalwire.com. A resource may be assigned to an address, a phone number, or a SIP domain app by navigating to the bottom of the selections page. Resources are malleable, allowing assignment to multiple addresses. Further on in your development, these addresses can be reconfigured or removed at will. Every resource comes complete with a unique identifier called an address. Addresses streamline development across Call Fabric by standardizing the ways in which disparate telecom vestitures are referenced and behave. Two constituents combine to create an address, a context and a name. Likewise, SignalWire spaces are bound by a pair of contexts, public and private. A public context is accessible by anyone, while a private context is only reachable via a subscriber. The delineation of these contexts helps to promote the structure and security of communication workflows. The second resource example I'll add to my live transcription demonstration is a SWML script. Coinciding with the rollout of Call Fabric are a few quality of life improvements for our Space UI, namely a dark mode toggle for our SWML editor, an auto-formatting feature reminiscent of popular IDEs. In addition to auto-completion of SWML's methods and parameters, YAML and JSON script validation are also primed for a future release. The first major focus of my SWML script is the newly introduced live transcribe method. With it, my Node.js application will be outfitted to extract real-time transcriptions of incoming calls. Illustrated later on in this guide, conversation logs and AI-generated summarizations may be passed along to this call monitoring app via webhook for custom reporting and analysis. Across Call Fabric, SignalWire seeks to circumvent what would have previously been a confusing patchwork of webhook URLs by empowering methods like connect to plainly reference a resource address. I'll use this opportunity to reference the call flow resource I designed moments ago. Before exiting my SWML script resource, I'll associate it with the phone number I purchased earlier. With the final segment of my live transcription demonstration, I'll develop a call monitoring application using Node.js. For a complete code sample, braiding call data, conversation logs, and AI-generated summarizations into a robust CSV report, visit our SignalWire in Seconds GitHub repository. From the top, I'll use the Express framework as a foundational weave, holding the composition of HTTP post requests and responses together, and establishing a seamless flow of information from SignalWire to my application. Like elastic, interwoven threads, Body Parser middleware stretches to provide a JSON-like experience for the handling of URL-encoded form data. Next, I'll fashion the call array to resemble a textile's recurring motif. Each conversation will transmit inbound call details, such as the from number and the to number, that are set to be recorded in an overarching pattern. Just as a conservation stitch safeguards a garment from unraveling, my onExit function ensures that conversation info is not lost when I close the app. Instead, I'll elect to compile the session's call data into a CSV report. My incoming calls and transcription application routes are akin to a loom, feeding the calling info I requested into my defined data structures. Like an artisan, ever mindful of the integrity of my work, frequent console log updates allow me to observe each call's progress in real time. To tie the threads of our call fabric and live transcription demonstration together, let's make a test call.
Welcome to the SWML application resource for SignalWire in Seconds. Please stand by while we transfer you to an IVR.
Okay, will
Thank you
do.
for reaching out to the SignalWire in Seconds call flow resource. Please press 1 to be transferred to a technical success manager.
Pressing 1 now. Wow, that's really loud.
Did you hear it?
Yes, I did.
The distant sound of a sewing machine. As we tether together the high-level primitives of Call Fabric, the advantages of programmable unified communications begin to materialize. Thank you for joining us today. Goodbye.
You're welcome. Goodbye. Entwining top-level telephony primitives like AI agents, markup languages, and visual builders. Call Fabric empowers developers to expeditiously deploy vestments of communication with greater flexibility, scalability, and interoperability. Felling threadbare on-prem systems by harnessing a robust cloud-agnostic infrastructure. SignalWire outfits businesses with intuitive voice, messaging, faxing, and video conferencing resources. To unravel the whole ball of yarn and learn more about crafting custom communication experiences with ease, check out our companion blogs at signalwire.com. That's all I have for today. For more SignalWire in Seconds, Be sure to smash that subscribe button below.